As we discussed previously, that with the flag bits, probability of an error going undetected, especially if the CRC part is not processed or is wrongly interpreted, is quite serious. So we looked at the problem and we also said that we are going to seek a possible solution. The obvious solution is not to start and end the frame with flag bits, but instead use another combination. For example, some kind of the length field that is included in the header and identify the start and end of the frame. In this module, we shall investigate length field by looking at its purpose. If the length field is incorporated, how much additional overhead it is posing, the problems that could arise with the length field itself, and the resulting complications for the whole frame processing. And then we are going to look at some of the solutions which are providing partial management of such length field related errors. The reference for the discussion currently on is Verticus and Gallagher. This reference is of fundamental importance because Data Networks as a book is followed worldwide in some of the well-known universities all over the world. The book goes through mathematical rigors along with explaining the underlying principles which govern certain algorithms and layers. The purpose of the length field is quite similar to what we used the flag bits for. That is, to inform the receiving data link control about the ending fill bits, because these fill bits were used to synchronize the modem when no data is being sent. So when these fill bits stop, the next legitimate data frame has to start. So the length field tells when exactly does the frame start and when does it end. Generally, the frame length is part of the header that includes miscellaneous information such as the destination address, the source address, and information about the upper layer protocols. If the length field is represented by ordinary numbers, binary numbers, it means, say, we are using 4 bits to identify the length of the frame, then we could have up to 15 bytes worth of data in the frame, including the header. So the number of bits in the length field has to be governed by the mathematical relationship. That is, if the frame size is k max, then we need to take the logarithm of it to the base 2. As I just said, for representing 15 bytes worth of data, we need to take its log. So 15 plus 1 is 16. To the base 2, we need at least 4 bits. Apparently, length field seems to solve the problem that we were facing with the start and end flags. However, any error that occurs within the length field could have similar implications with regard to cyclic redundancy check. For instance, any error in the length field could confuse the receiver to look for the CRC at a wrong place. As a consequence, what would happen? That an incorrect frame could be accepted because somehow, let's say, the CRC matches because of error with the data stream. Of course, the probability is again governed by L, which is the length field. So for a longer length field, the probability for it getting corrupted is less. The receiver does not know where to look for subsequent frames because the length field has told it to misinterpret the overall length of the frame, so the subsequent frames would also be affected. If we look at the solutions which could possibly be seen with regards to combating errors on the length field, the DECnet uses fixed length header for each frame. So that's the first thing, that the header length has now been fixed, and the position of the length field in the header is also pre-known. And in addition, the header incorporates its own CRC. So if something goes wrong with the header, including the length field, it could be easily identified using the CRC in the header. However, the limitation of just wasting this corrupted frame and asking for resynchronization after such an error has taken place is needed, because the frame has actually been detected to be in error, but the length field of the next frame has to be exactly synchronized. Otherwise, the sender and receiver would never be able to identify where exactly the length field is placed within the fixed length header. And consequently, the receiver would certainly not know when the next frame starts. As an alternative solution, we can also put the length field into the trailer of the preceding frame. That is, the preceding frame, which has CRC in the trailer, we put the length field for the next frame in the previous frame. It is going to, of course, result into lesser redundancy, because in DECnet, 2 CRCs meant more redundancy. However, it requires special synchronization because, like DECnet, if the trailer is corrupted, then some resynchronization has to be done for transmitting the frame with the trailer, including the CRC and the length of the next frame.